All right, welcome back to video 2 on the binomial theorem. So for this video, we're going to be looking at making a wager on making 90 out of 100 free throws. So suppose you have an 80% chance to make each free throw. What's the probability you make 90 or more? So to type this into our calculator, we put the chance for success, 0.8, number of trials at 100, and then we want to calculate 90 successes. So down here we can look. The chances for making exactly 90 free throws, pretty small, 0.003, so 0.3%. The chances of making x less than x, so our x value, lowercase x, is 90. So we want to find the chances we make less than 90. So really high chance, 99%, 0.99, that we make less than 90, which makes sense because it's really hard if you think about our big Plinko tree. It's really hard even at an 80% chance to get to 9 out of 10 or more on average. So the cumulative probability x is less than x. So capital X is less than or equal to lowercase x. So less than or equal to 90, pretty much about the same. That's just counting the 90. Now here is what we're interested in, making more than 90 or making more than or equal to 90. So we want to look at the bottom one, because this is making more than or equal to 90, so 0.00569. We move that decimal 2 spots to the right, so 0.569 would be our percent. So about 1 in every 200 times we're going to make this happen. Okay, so that's how we read those probabilities. Next, we could think about our chances for success, which is, so we want our chance for making 90 or more would be down here, 0.00569. And so on here, we want to use that 0.00569 chance for success on our 100 free throw wager. We want to figure out how many times we would need to run this simulation in order to get an 85% chance of success. So inside of here now, we're going to use our chance for success. And I played around with the number of trials. I found out that in about 333 trials, and I put the chance for success at 1, we would have, so to get 1 or more, sometimes we would be successful more than 1 try in terms of shooting the 100. So to have an 85% chance for success, we would need to do this 333 times. So we'd have to shoot 100 and then shoot another 100. So that'd be a lot. It'd be 33,300 free throws to have an 85% chance of success. Now, if you were doing this in real life, you could, if you missed the first 5, you could just reset. You wouldn't have to shoot out the last 95. And so there we go. That's how we use binomial distributions. This actually did happen. You can read about this online. This person wagered a lot of money and was able to make 90 out of 100. It took them only, I think, 77 tries, but they were able to reset. If they missed the first 5, as I said, they just reset. So, but it took a lot of time and practice. I think they ended up being better than an 80% free throw shooter too, maybe like an 85%. So let's do a little more of one more example. Here we have an art supply catalog. There's 560 pages. 8 pages feature a signature artist. We're going to randomly look at 100 pages, and we're going to let X be the number of pages featuring a signature artist. And so X is here, the number of signature artists. So here we go. We're looking for, as we look at the 100 pages, we could get 0 or 1 or 2, all the way up to the 8. There's only 8 signature artists, so we can't get more than 8. And so this is a binomial distribution, since each event is independent. And we have 100 pages we're looking at, and the probability of success is 8 out of the total number of 560 pages. So to do this, we're going to take it into our calculator again. We want to find these probabilities. The probability that 3 pages feature signature artists out of the 100, at most 3 pages, or more than 3 pages. Okay, so I took my probability of success, 8 out of 560. I used my calculator to convert that to a decimal. 100 trials, so that's the chance for each signature artist, 100 pages, and we're looking for 3 successes. So the probability that 3 pages feature a signature artist, about 11%, 0.116, or 11.5. Probability at most 3 pages feature a signature artist. So that would be up to 3. So that would be down here, less than or equal to. So that would be 0.944. So pretty common. We get at most up to 3 signature artists. So 94%. Probability more than 3 pages feature a signature artist. This is going to be tough to do. So more than would be down here. So we're looking at more than 3. So 0.055. So about 5.5%. So that's how we use these probabilities to answer these questions. We could go ahead and calculate the mean and the standard deviation for the art example. We have 100 pages. Here's our chance for success. So we multiply the number of trials multiplied by the probability of success. So on average, as we look through those 100 pages, we'd get about 1.42 signature artists per time we look at the 100 pages. And here's how we calculate the standard deviation, square root of the number of trials, probability of success, probability of failure. All right, and that concludes this lesson.